a substance decays exponentially. It's initially 100 grams. So this is going to be a Q of 0. But there are 40 grams left after 5 days. Okay, so exponentially means I can write down right away that Q of t equals C times e to the at. And we said Q of 0 equals 100 grams. And after 5 days, so Q of 5 is 40 grams. This is all the information I need to find my unknown C and A. In fact, the initial one, if I plug in t equals 0 in this expression, I'm gonna get just C, and C will be then equal to 100. If I plug in 5, t equals 5 in my expression here, then I'll get C times e to the a times 5 equals 40. So 100 times e to the 5a equals 40. I have to divide by 100 on both sides. So I get that e to the 5a is equal to 0.4. I take ln, so ln e to the 5a equals ln 0.4. ln and e go away, so I'm left with 5a equals ln 0.4. So a is equal to ln 0.4 over 5. At this point you can actually plug it in the calculator and see what you get. So you write the equation, the equation of the substance at time t. It's going to be C, which is 100, times e to the a, which is given here. So ln 0.4 over 5 times t. And that's final answer for part A. Part B is asking how much substance after 3 days. So 3 days is time, and what we want to know is our unknown is Q. So we want Q such that T is equal to 3. In other words, we want Q calculated times 3. So we just plug in. This is 100 times e to the ln 0.4 over 5 times 3. And you can plug it in the calculator to get exact number of grams. Part C. So here we have 10 grams are left. So we know what's the substance. What we don't know is the time. And in fact the question is when. So we want to find out a time. So our unknown is a t such that quantity at that unknown time is 10 grams. So we plug our expression for Q of t. So this is 100 e to the ln 0.4 over 5 times t equals 10. And we solve in the same way we solved for A. So we divide by 100, so we get e to the ln 0.4 over 5 times t equals 10 over 100, which is 0.1. Then take ln, and you cancel ln and e, and you're left with the exponent, which is ln 0.4 over 5 times t equals to ln 0.1, and therefore t equals 5 ln 0.1 divided by ln 0.4. For part D, you apply the formula for the half-life. So you can just say T half-life is equal to negative ln2 divided by A. So negative ln2 divided by ln 0.4 divided by 5, which is 5 ln2 divided by ln 0.4. And that's going to end up being a positive number because ln 0.4 is a negative number. So you have negative of a negative number. It's going to be positive. Or you can pose this problem as saying we want an unknown time, half-life, such that quantity at that time is half the original quantity. And then we would plug in all the expression for Q, and then you would end up with the same answer.